Tutorial 6. Under question number 1, under an employment promotion program, it is proposed to allow sale of papers inside buses during peak hours, so the vendor can purchase newspapers at a special concession rate of 1.25 against a selling price of 1.50. Any unsold, however, a dead loss. A vendor estimated the following probability distribution, the number of copies demanded. So how many copies can be sold so that the expected profit is maximal? So in this case, we're going to calculate not only the number of copies, but also the expected profit. This is called a random variable. A random variable. Firstly, we're going to identify that the number of copies will be denoted by the letter X. And our probability Px. So the number of copies, basically we're multiplying the number of copies here by the probability. So Xpx, that we get the total. So we're going to multiply 15 by 0.04. But we get 15 times 0.04. We're getting 0.6. (16) times 0.19. We're getting 3.04. (17) times 0.33. We're getting 5.61. 18 times 0.26. We're getting 4.68. 19 times 0.11. We're getting 2.09. 20 times 0.07. We're getting 1.4. So when we add all these, 0.6 times plus 3.04 plus 5.61 plus 4.68 plus 2.09 plus 1.4, giving us 17.42. That is the mean number of copies. So our mean here is 17.42. So the number of copies that we expected, about 17 newspapers to maximize our profit. Now, what is the actual maximum profit? We calculate our new what? X. The selling price minus the cost price. So 1.5 minus 1.25, what do we get? 0.25. So we'll multiply this 0.25. So our question ends there. I'm just trying to amplify it because this question can also be asked for you to calculate the actual profit that is made. 0.25 times 0.25 times 0.25 times 0.25 times 0.25 times 0.25. So what is our X? So 15 times 0.25, we get 3.75. That's our new X. When we multiply it by the probability 0.04, we're getting 0.15, our x dx 0.15. Then 16 times 0.25, we're getting a 4. It's 4 multiplied by the probability 0.19, we're getting 0.76. 17 times 0.25, we're getting 4.25. That is our profit. When we multiply it times probability of 0.33, we get to 1.4. Next, how do we do? How do we do next? 18 times what? 0.25, which is 4.5. And what do we do to 4.5? Multiply by the respective probability, 26, 0.26, which is 1.17. Next, 19 times 0.25, get 4.75. And what do we do to the 4.75? Multiply the respective probability, which is 0.5225. Then 20 times 0.25, we get a 5. Then multiply the 5 times 0.07, what do we get? 0.35. This one is just helping us find the actual profit. So 0.35 plus 0.5225 plus 1.7 plus 1.4025 plus 0.76 plus 0.15. So the total is 4.885. 4.885. So this means we're going to sell 17 copies for a maximum profit of what? 4.885. Is that clear? So that is how you calculate the random variable. Random variables are very easy if you understand the concepts. Okay. So we'll skip question 2. We'll look at question 3. Question 3, we're given the values of x, and the frequency is simply the same as the probability of x. So to find the expected value, which is a mean standard value, we first can square these individual numbers. Square of 0 is 0, square of 1 is 1, square of 2 is 4, square of 3 is 9, square of 4 is 16, square of 5 is 25. Then multiply the values of x times the probability. So this should be x dx. The total is called the mean. 0 times 0.10 is 0. 1 times 0.3, 0.3. 2 times 0.4, 0.8. 3 times 0.12 is 0.36. 4 times 0.06, 0.24. And finally, 5 times 0.02, we get 0.1. So in total up, 0.1 plus 0.24 plus 0.36 plus 0.8 plus 0.3 plus 0, we get 1.8. So 1.8 is actually our mean. Simply the summation of x times probability of x. Then next we multiply the square times the probability, what we had squared. So x squared times the probability. So 0 times 0.1 is 0. 1 times 0.3 is 0.3. Are we following? 4 times 0.4, 1.6. 9 times 0.12, 1.08. 16 times 0.06, 0.96. And finally, 25 times 0.02, 0.5. So when you total up there, 0.5 plus 0.96 plus 1.08 plus 1.6 plus 0.3 plus 0, we get 4.44. 4.44 is the summation of x squared px. So to find the variance is simply what? The summation of x squared px minus the mean squared. For this 4.44, we subtract the mean that we found. What was our mean? 1.8, but the square of 1.8. So when we do that, we're going to get 1.2. 1.2 is a variance. So meaning the standard deviation is simply the square root of the variance. So standard deviation is square root of 1.2. So to square root that, we're going to get 1.095. 1.095. That is our standard deviation in that regard. So actualizing it, market researcher at a mobile company classified households by car ownership. The relative frequencies of households for each category of ownership is below the number of households and the frequency. So how many households had cars? On average 1.8. And the variation from 1.8, which is standard deviation, is 1.095. That is how we can interpret it. All right, so we have another question here. We're told in this question, we have the following data. A company introduces a new product. So we're going to bring in the states of nature that we have. State of nature simply condition or scenario at that point. So in this market, it expects to make a profit of 2.5 in the first year if the demand is good. So when the A is good, our expected return is what? 2.5. That's the value of X if you want. Then 1.5, it's moderate. So moderate 1.5. And if poor, we're going to make a loss of 1. State of nature poor, the loss is negative, so -1. Now, given the probabilities as follows, that the market indicates that if it is good and moderate, it's 0.2 and 0.5. Nothing is said about poor, but we know that the total here must be 1. So when you total up here, this is 0.3. We are being asked to now calculate expected profit and the standard deviation. So the return times the probability. The total is called the expected return. So 2.5 times 0.2, we get 0.5. 1.5 times 0.5, 0.75. One times 0.3 is negative 0.3. When you add this, we're going to get a total of 0.95. So our expected return is what? 0.95. So you find the variance and standard deviation of each of these returns and subtract the expected return. So the return minus the expected return. So 2.5 minus, then we can apply the probability after we square it. So return minus expected return. So we're going to subtract 2.5 minus what? 0.95. We get 1.55. Square this 1.55, we get 2.44025. And we multiply this one by the reciprocity probability here, 0.2. So we get 0.48. We start afresh again here. 1.5 minus 0.95. 1.5 minus 0.95, we get 0.55. Then what we do is 0.55. We square the answer there. We're going to get 0.35. Multiply this number times the probability. This is probability times the answer behind. So what's the probability? 0.5. But we get 0.15125. Lastly, minus 1, 0.95. What we get? 1.95 negative. 1.95, when you square it, we get what? 3.8025. 0.825, when you multiply it by the probability, 0.3, what we get? 1.14075. What we get is what the variance, and we send the square root it to get the standard deviation. So we'll add these answers, 0.15125 plus 0.4805. So what you get is 1.7725. This is what the variance. The square root of that answer, 1.331. That is how you calculate the standard deviation. In like manner, I could still say the method that I taught you at first. If you're comfortable with it, the values of x is 2.5, 1.5, negative 1. And you can square the values of x here. 2.5 squared, the 6.25, 5 squared, that is 2.25, and 1 squared is 1. We got the probabilities. 0.2, 0.5, and 0.3. We find the mean, it just multiply x times the probability. So xpx Here we get 0.5 here. We get 0.75 here. We get negative 0.3. So this 0.95 is our mean. Then to get the variance, now apply this and that one. So 6.25 times 0.2, we get x squared dx. This is 1.25. And 2.25 times the probability, which is 0.5, we get 1.125. Okay, then 1 times 0.3, we get 0.3. So we add them, we can then subtract, we can then find the standard deviation. So we add these two. So let's go through it again. When we got the values of x, we squared them. Value of x squared, the value of x squared, then define the mean. We simply multiply 2.5 times 0.2, we get this. 1.5 times 0.5, we get this. Negative 1 times 0.3, we get this. The total is called the mean. Is this clear how to get the mean? When you square this,
Yes.
you get 0.2. 0.2 times 6.25. Get 1.25. Then 2.25 multiplied by 0.5. We get 1.125. Then 1 times 0.3, we get 0.3. Then when you add this, 1.25 plus 1.125 plus 0.3, you get 2.675. Let's compare that answer. Get 1.6355. Okay. Again, it's supposed to be the same. Maybe there's a disparity in one of the things, but this is what you're supposed to do. All right, let's go to our next question. Everything is surrounding random variables. That is binomial. Are we clear on random variables? So this is our random variable supposed to be tackled. And we go to question number 4. Question number 4 has to do with binomial distribution. So bi means 2. When I'm dealing with binomial distribution, you must understand the formula for binomial is given by what? X is n combination x, px, qn minus x. So if we're given our n maybe as 10, our p maybe as 20%. So the mean is simply np. The variance is simply npq. And the standard deviation is simply square root of the variance. 10 times 0.2, this is 2. 10 times 0.2, 0.8. But we get our variance. 6. The square root of the variance, the standard deviation, which is square root of 1.6. 1.26. That is how we calculate that. Then if you're asked to find the probabilities of x is equal to 0, 1, 2, and 3, you just find the combinations of each of them based on the sample size. So x, n combination x, so for 0, it is 10 combination 0. For 1, it's 10 combination 1. For 2, it's 10 combination 2. For 3, it's 10 combination 3, and so on. So I'm going to look at these ones here. Our probability in this case is 0.2. So meaning the remainder to get 100 is 0.8. So our Q is 0.8. 0.8, 0.8, 0.8. So in here, according to the formula, the 0 comes on the 0.2, the remainder, 10 minus, because this is n minus x, so 10 minus 0 is what? 10. And here, the 1 comes here, the difference, 0 minus, 10 minus 1 is equal to 9. The 2 comes here, yeah, 10 minus 2 is 8. Then compute them here. So this is 1 times 1, and 0.8 to the power 10 gives you 0. What? 1073. So 1073, we get that. And here, 10 convention 1 is 10. 0.2 to the power to 0.2. 0.8 to the power 9. 1342. So applying all these will give you the probability of getting 1. It's in 684. When you do 10 combination what? 2. This is 45. 0.2 to the power 2, 0.04. 0.8 to the power 8 is 0.1678. 678. We multiply this by 45 by 0.04, we get 30, 20. So these are the individual probabilities. If they ask you exactly 0, that's a figure. Exactly 1, that's a figure. Exactly 2, that's a figure. If they say at most 2, means 2 and below, you add 2, 0, and 1, all these ones. At least 2, it means 2 and above. So it means 2, 3, 4, 5, 6, upwards. So the opposite is simply 1 minus what is not listed there, probability of what? 0 and 1. Then you get the difference in the answer. That's where the tricky part is. So let's actualize now this question that has been asked. That in a brokerage report shows that investors have a discount broker. And that does not charge full commission. In a random sample of 9 individuals, what's the probability of exactly 2 individuals being used as discount brokers? Not more than 3, at least 3. So binomial is the easiest in the sense that you're able to identify only 2 things. Number 1, the n, which in this case is 9. Number 2, the p, which in this case is 30%. Meaning our q is 0.7. Able to identify that. If our p is given, then our q is a brainwave. So part 1, exactly 2. So we're looking at exactly 2. So this is 9 combination what? 2. So where there's p, we put 0.3. Where there's q, put 0.7. The 2 comes here, and this 9 minus 2 is 7. So what is 9 combination 2? Can use a calculator. 9 connection 2, we get 36. 0.3 to the power 2, I get 0.09. 0.7 to the power 7, it's 0. What? 0.08. So you apply this times 0.09 times 36, we get 0.2668. That is for exactly 2. And no more than 3 means don't exceed 3. So let's say equal to 3. So what we're looking for, no more than 3 means for a bit of 0, 1, 2, and 3. Since we already have the probability of 2, we can just find the others, 0, 1, and 3 itself. What's the probability of 0? What's the probability of 1? What's the probability of what? 3. So this will be 9 combination 0, 0.3 to the power 0, 0.7 to the power 9. And here 9 combination 1, 0.3 to the power 1, 0.7 to the power 8. How about combination of 3? 9 combination 3, 0.3 to the power 3, and 0.7 to the power 0.7 to the power 6. These two must add up to the top guy. So here we have 0.7 to the power 9. For the rest, this is 1, this is 1. So here we're going to get 0.04. Here, this is 9 and this is 0.3. So just find 0.7 to the power 8 times 9 and 0.3. We get 1556. 1556. And here, 9 combination 3, which is 84. 0.3 to the power 3, 0.007, 0.027, 0.7 to the power 6, 1176. Multiply by 0.027, multiply by 84. And answer I get is 0.2668. Then we already found the probability of what? 2, which is this one here. So just add all of them as 0.04 plus 0.1556 plus 0.2668. 2668. Okay. So when you add all these, we're going to get 0.7292. So the total, including this one, 0.7292. So this is the probability of having no more than what? No more than 3. At least 3 means probability of 3 and above. So this is greater or equal to 3. So we're looking at probability starting from 3, 4, up to the last number 9. But this will take us a whole day. The shortcut will be 1 minus the missing numbers. So probability of 0, that's probability of 1, that's probability of 2, that's probability of what? Of we add 3? No, we don't add the 3. So this one is probability up to 3. We just remove one of them. 0.2668. Okay, so here we're going to get what? 1 minus 0.4624. we end here. We'll continue the next session, and that is our answer. Thank you so much, and have a great day. Please attempt the other questions at your own time. I'll send them through. Have a good day.